All right, so I may or may not have made a mistake in my last video, so we're going to try again. Divide the following using either long or synthetic division. You must use each at least once. This right here, we're going to use long division for. The only thing we can use synthetic division for that you've learned so far is x minus k, if your divisor is in the form x minus k. So the only one that actually works for that is number 2. All right, so I'm going to divide 15x cubed divided by 5x squared is 3x. Apparently, I didn't know that before. 3x times negative 4x is negative 12x squared. 1 times 3x is 3x. Go ahead and draw your line and change your signs. This makes it so that you can just add instead of subtract. It's the same thing, though. We're adding negatives, which is the same as subtracting. So we have 23x squared plus 12x squared is 35x squared. And then minus 28x. And then because your divisor is 3 pieces, it's a trinomial, you need to have 3 pieces down here. Okay, so we'll drop the negative 3. And then we start it all over. Divide 35x squared divided by 5x squared. That would be a positive 7. Multiply 5x squared times 7 is 35x squared. Negative 4 times 7 is negative 28x. 1 times 7 is 7. Draw your line and change your signs. And then we can add. That's 0. Negative 28x plus 28x. That's also 0. Negative 3 minus 7 is negative 10. That's my remainder. So I'm going to subtract 10 over the divisor. 5x squared minus 4x plus 1. So this one is the only one that we have learned so far how to do synthetic division in. Okay? Synthetic division is that box thing. Check for missing powers. You have 4, 3, 2, 1, 0. All right, we have no missing powers. So we're going to put the coefficients 10, 27, negative 4, 14, and negative 6. We're dividing by x minus k. So we're supposed to put k outside of here. When your general form is minus, that means you need to change the sign. So if it's n plus 3, k is actually negative 3. Synthetic division is like dominoes. The first one has to fall for you to start. 10 times negative 3 is negative 30. Now you're going to add vertically. That would be negative 3. Negative 3 times negative 3 is 9. And then we're going to add vertically. That would be 5. Multiply diagonally. 5 times negative 3 is negative 15. Add vertically. Negative 1. Negative 1 times negative 3 is 3. Add vertically. Negative 3. All right, the degree of our dividend is 4. The degree of our divisor is 1. So the degree of the quotient must be 4 minus 1, must be 3. So this would be... So the degree of our answer, we only divided out one variable, so it's 1 less than the dividend. If the dividend is a quartic, then our quotient will be a cubic. So this is a 4. Our answer is going to have x to the power of 3. This one has x to the power of 2. This 5 is positive, so I'm going to put plus 5. Make sure there are signs in between there. 5x, then it's minus 1, and then it's minus 3. So 1 is the constant. That's the number that has no x attached to it. And then negative 3 is your remainder. So what you'll do for negative 3 is go ahead and put it over the original divisor, n plus 3. Oh my goodness, yeah, I used x instead of n. I'm so used to using x because I prefer it. So yeah, the variable for this one is n, my bad. Yeah. All right, here we go. That is our answer. All right. You can actually solve this one with synthetic division, but it involves a fraction, and I would rather just work with long division. Most of us are more comfortable with that. So when we set it up, make sure you're not missing any powers. 5, 4, 2. We're missing a cubic. So we need to put plus 0n cubed to make sure that we have a column for the cube, for all the cubed terms. 2, 1, 0. You could have multiple missing powers, so make sure to check the whole thing. 10n to the 5th plus 8n to the 4th minus 10n squared. Plus the 0n cubed that we just added in minus 10n squared minus 18n minus 13. 10n plus 8. All right, go ahead and divide. 10n to the 5th divided by 10n is 10n to the 4th. Is n to the 4th. Not 10. N to the 4th. Lovely. 10n times n to the 4th is 10n to the 5th. Multiply 8 times n to the 4th is 8n to the 4th. Draw your line and change your signs. That's 0. This is 0. So we have 0n to the 4th plus 0n cubed. Okay. So 10n goes into 0 times. And so I end up getting 0 and 0. I'll go ahead and put this in the cubed column. It would be cubed, so 0n to the 4th, 0n cubed, just to kind of keep my columns in order. But again, 0 minus 0 is just going to be 0. So draw your line and change your signs. And I end up with 0. And we're going to drop the next one, negative 10n squared. 10 goes into 0. Again, 0 times. Cool. So that's also 0 n cubed and 0 n squared when I'm multiplying. Draw your line and change your signs. All right, now I got out of the zeros, so now I have normal numbers to divide. Negative 10n squared divided by 10n would be negative n. Negative 1n. So now we multiply 10n times negative n is negative 10n squared. 8 times negative n is negative 8n. Draw your line and change your signs so you can add. Negative 10n squared plus 10n squared is 0. Negative 18n plus 8n is negative 10n. Drop the negative 13. 10n goes into negative 10n negative 1 times. Multiply 10n times negative 1 is negative 10n. 8 times negative 1 is negative 8. Draw your line and change your signs to add. That's 0. This is negative 5, and my remainder is negative 5. So you'll subtract 5 and put it over the divisor. However, this has a bunch of zeros in it. This is not really a clean looking quotient, so please rewrite it. We don't need any of those zeros written in the actual answer, okay? So make sure you rewrite it so that it would be n to the power 4. That one doesn't need to be there. This one doesn't need to be there. Minus n minus 1 minus remainder over divisor. All right, so we're going to simplify and find those stated, state the excluded values. So first of all, factor anything that can be factored. The denominator only has 2 terms, but there is a GCF. So the greatest common factor would be 8 and x. If I take out an 8x, 8x times 3x gives me 24x squared, and then 8x times negative 1 gives me that negative 8x. All right. So I have an 8x here. I would like to reduce with this 16x. So I'm actually going to rewrite the 16x as 8x times 2 over our denominator that we have factored, 8x times 3x minus 1. This makes it really easy for us to reduce. So we have 8x over 8x is 1. And 1 times this is just 2 over 3x minus 1. Please remember to find those excluded values. Some of us forgot that on the quiz, so make sure you remember to find the excluded values. How do you find excluded values? Go to the factor denominator that you made, take that, make it equal to 0, and whatever you get, that's the excluded value, because it should not, your denominator can never equal 0. So 8x times 3x minus 1 equals 0. Or it should not equal 0, right? So you can actually use the zero product property to solve this. 8x equals 0 and 3x minus 1. Three x minus 1 equals 0. 8x equals 0, so divide both sides by 8, and you get x equals 0. So one of my excluded values is 0. And then solve for this one, we add 1 on both sides, 3x equals 1, x equals 1 divided by 3. So the two things that x cannot be 0, x cannot be 1/3. All right, we're going to simplify each expression. And guess what's the best way to do that? Factor, factor, factor. My students love to factor. I'm watching their reactions right now. They're not 100% pleased with my sharing of that. Moving on. So we have, ooh, this one's kind of got big numbers, and it doesn't appear, there doesn't appear to be a GCF. So 7x times x gives me 7x squared. There are several things that are going to multiply to give me 12. So I'm going to put them over here. 1 times 12, 2 times 6, 3 times 4. And I'm going to test things out. Okay, so I'm trying to get a 25. I have a 3 and a 4. I'm thinking if I multiply the 3 times 7, then I'm going to get 21. That would get me closer to 25. So let's try that. If I put 3 times 7, that would be 21x. And then 3 times 4 equals 12. So let's see if that gives me 21x. 7x times 3 is 21x. Sorry, 25. 21x plus 4x is 25x. If both signs are positive, both signs are positive. All right. So that is the factored version of your numerator trinomial here. And then we have everything else has been factored. So if you have anything on the top and that's the same as anything on the bottom, you can go ahead and reduce that. So 7x plus 4 over 7x plus 4 is just a special form of the number 1. So on the numerator you have 1 times x plus 3 times 1, which is just x plus 3. And in the denominator you have x plus 6 times 1 is x plus 6. Can we reduce that? Maybe the x's, can we do that or that? No, we can't. It's done. That's it. Yay. So when we divide fractions, we actually want to change it to multiplication and multiply by the reciprocal. Okay, so what I'm going to do is rewrite this with the second fraction flipped. All right, 1 over 2n plus 10 times 2n squared plus 20n plus 50 over n plus 2. All right, so let's factor anything that we can. There's a GCF for these two, which is 2. that would be n plus 5 is left there. And then this one I can factor. This is a trinomial. There is a GCF, which is 2. N squared plus 10n plus 25. And you can actually factor that one step further using p's and q's. So what we have, so this got a little bit messy because of all the factoring, so I'm going to rewrite. This is 1 over 2 times n plus 5 times the top is now, the fully factored numerator is now 2 times n plus 5 times n plus 5. You could write n plus 5 squared, but I know that only one of them is going to reduce, so I'm going to leave them separate. And then over n plus 2. So if it ever gets too messy, just rewrite it down in a separate step, and that might help you to see what you need to reduce when you're doing the test. Okay, so now I have 2 divided by 2 is 1. N plus 5 divided by n plus 5 is 1. So my numerator is 1 times 1 times 1 times n plus 5, which is n plus 5, over 1 times n plus 2, which is n plus 2. Can I reduce the n's? No, I cannot. That is that.